Okay, so what we're going to do in this video is learn how to factor perfect square trinomials, which is actually something you already know how to factor because they factor just like regular trinomials. And included in this section is factoring completely. And really, so the focus of this video is going to be on all the different kinds of factoring methods, all of which will be on your upcoming quiz. And so this is going to be a little bit of a review of all factoring, and the new concept will be perfect square trinomials, but like I said, you already have the method for solving those, so I'll just show you what actually turns out to be a slightly different result. Okay, so what we're going to do here is we have something called a perfect square trinomial. As far as you're concerned, though, you've got to look at this as just a regular old trinomial with nothing particularly special. What ends up being special is that the answer, the final solution to the factoring problem ends up being the square of a binomial, but that, like I said, doesn't really make any difference to the way you approach it. Okay, so we've been asked to factor. We have a trinomial, 1, 2, 3 terms, and so what we're going to do is we can open two sets of parentheses because we know the answer, if it factors, of course it might be prime, the answer is going to be a binomial times a binomial, 2 terms times 2. Start off and look at the factors of x squared, and in this case we have x and x. Look at the factors of 4, and our options here are 4 and 1, 2 and 2. We can then use the sign over here to give us information. If it's a positive, we know for sure that the signs are going to be the same. They'll either be both plus or both minus. And then if we look over to the middle term, we can see that they would both be minus. So in this case, I could put those straight in there because there's no other way that that can work. And we're just going to test which pair of factors is going to add and subtract to get me to minus 4. So remember, we multiply to get the first and last term. We add and subtract in order to get the middle term. So here we have minus 1x, and here if we do x times minus 4, we have minus 4x, and minus 4x minus 1x does not give us minus 4x, so we know those factors aren't going to work. We test the second set. X times minus 2 is minus 2x, x times minus 2 is minus 2x, and if we were to add those two, we would in fact get our minus 4x, and so we know that our solution should be x minus 2 multiplied by x minus 2. As you can see from the answer, the binomial repeats itself, and so you can write that as a squared binomial, and that's why they call it a perfect square trinomial, because it comes from a binomial which is squared. But as you can see from the approach, this is irrelevant to the way you approach the question. Okay, so a little bit of a recap now. We've learned several different methods for factoring, the first of which was the greatest common factor, which involves removing any number or variable from each of the terms. We've factored trinomials. The easier ones have got an x squared. The more difficult ones have got the squared term with a number in front of it. Last class we did difference of two squares, and then we've also done grouping. And you can tell typically which kind of problem it is based on the number of terms. And so when we look at factoring completely, our approach needs to be very first step, remove a greatest common factor, and once we've done that, it may be possible that we are going on to any one of these three types of factoring problems. In trinomials, I'm of course including the perfect square trinomials that we just learned. As I mentioned several times, the method is the same. Okay, so now I'm just going to go straight in to each of the examples, which will highlight the different methods. Okay, and these are nicely set up for you because they tell you what you need to do. So we're going to start off by factoring these expressions by removing the GCF, the greatest common factor. So what we have here is two terms, and if you aren't confused by the parentheses, then hopefully you will realize that each of those two terms has an x minus 2. I'm going to remove the x minus 2, and what is left is 3x squared plus 2. and that is factoring by removing the GCF. And in fact, this is the precursor to a grouping factoring sum problem, and what we've done here is the second step typically of that grouping. So this is actually in a sense a grouping factoring, but we really just use the GCF. Okay, GCF for the second question. So I'm going to look at 14 and 4 and figure out the biggest number that can be divided into each of those. And so in this case I'm going to take out 2. I have an x to the power of 4 and an x squared. I want to take out the most that I possibly can, and so I'm going to take out an x squared in this case. Remember, when you take something out, effectively what you're doing is dividing, because factoring is the reverse process of distribution, and distribution is multiplying. So it is effectively the same thing as dividing each of those terms by 2x squared, and then I need to figure out what's going to be left. And so in this case we would have 7x squared minus, and then we have 4x squared divided by 2x squared is just going to leave me with 2. And that is the solution to problem 1b. Okay. All right, so let's move on. So that's a very quick review of GCF and, in a sense, grouping. And now we have a couple of trinomials. These are the more difficult trinomials because the squared term has got a coefficient which is not 1. Okay, so once again though, I'm going to come down here and open 2 sets of parentheses, because the answer, if it factors, is going to be the product of binomials. I'm going to come over here. In order to get 6x squared, it could be 3x and 1x, but we have a second set of factors. It could also be 6x times, I beg your pardon, this should be 3x and 2x, or 6x and 1x. In order to get the, so that gives us 6x squared. In order to get 2, we would have to have 2 times 1, and hopefully you remember from class, we also write this as 1 and 2, so that when we test the factors and we multiply, we can test the 6 with the 1 and the 6 with the 2 as well. And essentially at this point we are also going to figure out some information about the signs. We know that that is a minus, which tells us that our signs are going to be different, so that's the more difficult version. We're going to have 1 plus and 1 minus, but we have to be very careful about which parenthesis it's going to go into. Okay, so now what I'm going to do is start testing these, and what I'm after is a sum of plus 1x. So I'm going to start here, 3x multiplied by 1, 2x multiplied by 2, that's going to give me 3x, that's going to give me 4x, and fortunately for me I've stumbled on the correct answer straight away. If I add or subtract 4x and 3x, I can get to 1x, and so I can go straight to my answer at this point. I know it's going to be 3x and 2x. I need to put the 1 into this parenthesis to make sure that it's the 3x multiplied by the 1. And so let me just remove that. And then the second thing I need to do is put the 2 into this, and as before, that is to ensure that it ends up being 2 times 2x, so we don't mix that up. The last piece we need is to figure out which one gets the plus and which one gets the minus. If we have 4x and 3x and we want to get 1x, then we need the 4x to be positive and the 3x to be negative, and therefore by extension we need the 2 to be the positive and the 1 to be the negative. And so I'm going to do that. As you know, we can double check our answer using distribution, and so if we wanted to do that very quickly, we could say that's going to give us the 6x squared, that's going to give us minus 3x, that's going to give us plus 4x, and that's going to give us minus 2, and that will in fact simplify to 6x squared plus x minus 2, and that confirms that our answer is correct. Again, this is not a required step, but just allows you to check. Okay, speed things up a little bit because we're running a little low on time. And so the advantage of this question is with the number 1, the factors of 1 can only possibly be 1 and 1. That makes things a little simpler. To get 9x squared, it could be 9x and 1x, or it could be 3x and 3x. signs are going to be the same. They are both going to be minus. And so all we need to do now is test which of those will give us a minus 6x. And so hopefully you can see minus 3x is the one that we want. And our answer is going to be 3x minus 1 times 3x minus 1, which happens to be one of the perfect square trinomials. But you can leave your answer like that. There's no requirement to write the squared. Okay, now we see a slightly different instruction where it says factor completely. And what this is really warning you about is the fact that we could have a combined sum, where we have to remove a GCF first and then have a look at what is left inside. Okay, so what I'm going to do is start with the GCF. That's always what we want to start with. And so I'm going to see if there's a GCF here. Hopefully you see 4 goes into 4, into 44, and into 96. And each of the terms has got an x. So I'm going to remove 4x. It's going to leave me with x squared minus 11x. And that is going to give me 24, because 4 times 24 is 96. And of course the x's cancel. If you then look inside the parentheses, hopefully what you recognize is that that is in fact a trinomial. And so I have 4x. My trinomial will be x and x. My signs are going to be the same. They're both minus. And I need factors of 24, which will add and subtract to give me 11. And so we have 8 and 3. And that is our final solution for this problem. Okay. Same again for this one. What I'm looking to do is identify a term which is in all of these. So 2 is common to 2, 12, and 18. Y is also common to all of those terms. So if I remove 2y, I'm left with y squared minus excuse me, 6y plus 9. Once again, we look inside the parentheses over here. We have a trinomial, and so I'm going to open 2 sets of parentheses for the trinomial. I leave the 2y outside. In this case, we have y squared minus 6y plus 9. And so factors of y squared are y and y. Factors of 9, 3 and 3, 9 and 1. Signs are the same, they'll both be minus. And if I cross multiply, I can very quickly and easily see the first factors are going to work. And I have y minus 3 times y minus 3. And I've now factored completely, first by removing the GCF, and then by factoring the remaining trinomial, which happened to be a perfect square trinomial. Okay, I'm going to rush through the last 2 because of time. So all that happens now is this becomes solve, which means I just need to factor and then take it one step further with the zero product rule. So let's start off by factoring 3 terms. So I have a trinomial, factors of x squared, x and x, factors of 36, which are going to give me 12. So 36, plenty of factors, unfortunately. 36 and 1, 18 and 2, 9 and 4, 6 and 6, and I've missed one, 12 and 3. Signs are the same, they're both plus, and so I'm going to go ahead and fill in some of the information straight away. I have x, and I have both pluses, and all I need to do now is test which of these factors can add to give me 12, and you can see straight away it's going to be the 6 and the 6. X squared plus 6x gives me plus 12 plus 36. If the product of 2 numbers is equal to 0, that means x plus 6 equals 0, or x plus 6 equals 0. And in this case, the answer repeats, so my final answer, x equals minus 6. Very quickly for the last one, you must start an equation by moving everything to the left-hand side. So I'm going to equate to 0 first. And so what I'm going to do is add x squared to the left and subtract 1. And that's going to give me 4x squared minus 9 equals 0. Hopefully you recognize this as a difference of 2 squares. So imagine there being the 0x in the middle here. This factors as 2x and 2x, 3 and 3, 1 plus, 1 minus. And then we get final answers of x equals minus 3 over 2 or 3 over 2.